When you want to be able to drive your 1/24th and 1/25th scale plastic models, you're going to need some tiny RC electronics. After completing dozens of custom builds, today I'm going to be sharing some things that I've learned, as well as have a look at some of the products and techniques that I recommend for all you builders out there. So let's get those soldering irons warmed up and maybe bring out the magnifying glass, because today it's all about tiny electronics. Hello everyone and welcome! Today's video is the next in a series of informational type content that I hope will be helpful to all you builders out there. Several months back I made a similar type video on the topic of glues, which I'm very glad to see was helpful to some of you out there, and I learned a few things as well from some of you in the comments, so hopefully this video will be just as helpful, especially as this has been a commonly requested topic. Just a few things I want to say before we begin. First of all, this video is going to be from the perspective of someone wanting to build a very detailed and accurate scale model that is also radio controlled. I'm talking highly detailed suspension components, full interiors, basically maintaining a high level of scale detail with much less of a concern for durability or high-speed performance. There are a million and one RC products out there if you want to go for maximum speed and huge jumps, but that's not at all what these projects are about. You can certainly make them a bit spicy, but in all honesty, if you really want something to race around, a lot of the store-bought stuff, like a Mini Z for example, is really going to be the way to go if you want something that's more of an RC car first and scale realism second. What I'm really focusing in this video is more from the perspective of a model builder that just wants to add some functionality to their vehicle. The second thing I want to say is, while I'll be doing my best to make this video at least somewhat relevant to hobbyists who might not have much experience in this specific niche of the hobby, this video is going to assume you have some baseline knowledge of RC components and their function. For my own sanity, and to prevent this video from being 3 hours long, I'm going to try and do more of a basic overview rather than a full-on encyclopedia. Making one of these custom-built, highly detailed 1/24 scale models your very first introduction into the RC hobby is probably not the best idea, if I'm being honest. That's not how I got started, and as much as I enjoy these types of projects now, as clearly evidenced by my recent content here on the channel, I think you're going to find a lot of benefit from starting with a more well-established RC platform or modifying a ready-to-run vehicle. I think for most hobbyists, that's going to be a much better introduction into the hobby, and from there you can begin tinkering and taking on more ambitious projects and even custom building things from the ground up. In addition to a lot of the custom projects I like to showcase here on the channel, I also like to showcase some more basic builds like that Jeep Wrangler I modified in a recent video posted here on the channel. A project like that is going to be much better suited to a beginner, but that's really just my advice. If you want to jump right into these model car conversions, no one's going to stop you. Again though, do understand I'm kind of creating this video with the assumption that you have some baseline RC knowledge when it comes to what component does what and how everything goes together, as well as basic LiPo battery safety. And then as a final note, please always refer to the manufacturer's instructions and refer to the specs provided regarding what gets wired to where and how much voltage to supply. Some of these tiny components are easy to fry if you accidentally solder one of these wires into the wrong location or drip some solder into the wrong spot. I've definitely fried a few boards here and there, but that's just part of this niche of the hobby. When you're custom building stuff, you're probably going to have some failures from time to time. But personally, I just see it as part of this niche of the hobby. I enjoy the process and embrace the challenge. You win some, you lose some, that's just how it is. And if that's your philosophy as well, let's go ahead and talk about some of the required tools. Now obviously, one of the most important tools to talk about on the topic of electronics is a soldering iron. When you're getting into a lot of these types of tiny components, they aren't simply plug and play like what you tend to find with stuff designed for your more common larger scale vehicles. Soldering, or at least soldering well, does require some skill, so having a high quality iron, solder, and flux can make a huge difference, as I've discovered. It can help make a frustrating job only slightly frustrating. But I really can't stress enough, especially when you're working with some of these really tiny connections, how important it is to make these connections as secure as possible. Poorly soldered joints can not only cause the wires to become disconnected, which then you have to get in there and repair, but with these low voltage circuits, if you have a joint that's sort of on the borderline, you can start to get intermittent issues, to where sometimes it'll work, sometimes it won't, which can be even more frustrating to have to locate the source of the problem. Been there, done that. But really all of the soldering irons I own are pretty inexpensive ones that I've collected over time, and aren't the more fancy ones where you can adjust the temperature. They get the job done, but honestly, if you're looking for more information about what soldering irons are the best, or specific techniques for how to get the most solid joints, I really can't offer much advice on this topic, and I would instead suggest seeking out some other channels who might be able to provide more information about the soldering process. I know just enough to be able to do it, but not really enough to want to teach it or offer much advice if I'm being honest. Heat up the solder, stick the wires together, and hope for the best. There you go. But in addition to the soldering iron itself, helping hands and magnifying glasses like these are extremely useful, really bordering on being a requirement. They're not very expensive, and they're just super useful for a lot of different tasks. Now, for full transparency, I do want to point out that we sell some of these electronics that I'll be talking about on our site, and naturally I use a lot of these components for these projects, but I use a lot of components from other sellers as well. I don't want this video to come off as an advertisement for myself or any specific seller. I may include a few links below in the description, but really I just want this to be a showcase of what I use and why I use it. Obviously, these electronics we sell are ones that I like, but by no means are these the only options out there or necessarily even the best in certain situations, and I'll go through that more as we progress with this video. Please feel free to let us know in the comments what you like to use. There are tons of options out there, especially in recent years with micro-sized vehicles becoming much more common, so I'd be really curious to know what you all like to use for some of your more lifelike 1/24 scale builds. But let's go ahead and start with the basics. Just as I said before, this video isn't necessarily intended for an absolute beginner, so hopefully this will all be common knowledge here, but I do want to quickly go over some of the basics of each component necessary for one of these RC models. First, we have the transmitter and receiver. The transmitter is how we control the car, the receiver picks up the signal. Pretty simple. To steer the car, we have a servo, which receives a signal from the receiver, which is usually channel 1. Likewise, the ESC or electronic speed controller receives a signal from the receiver, usually on channel 2. It's responsible for powering the motor. The motor is what drives the wheels, and finally everything on the car is powered by a battery. Those are the 6 most basic components that really any RC car or truck is going to have: transmitter, receiver, servo, ESC, motor, and battery. Now in some instances, you'll have an all-in-one receiver and ESC combo, which combines both of these components. Likewise, you'll sometimes have an all-in-one motor and ESC, again combining the motor and ESC into one compact package. These can be nice for certain projects as they take up less space, which is essential when you're building a very scale vehicle that you want to look as lifelike as possible. Other electronic components may include things like additional servos for various functions like a winch, or LEDs for adding functional lights. Additional servos can be connected to the receiver if the necessary ports are available, while the lights can be powered either from the receiver, ESC, or simply connected directly to the vehicle's battery. Just make sure you have an appropriate resistor in place to prevent burning out the LEDs if you'll be connecting them to the battery directly. For convenience, some LEDs are sold with resistors pre-attached, like these here, which I can power off of up to 12 volts. There's no risk of burning them up with either a 1S, 2S, or 3S LiPo battery, but not all LEDs come with resistors pre-installed, so again refer to the manufacturer's specs to make sure you're not sending them too much power. Alright, hopefully we're all on the same page here when it comes to the basics, so now let's go ahead and look at some of the individual components that I like to use for my builds. When it comes to transmitters and receivers, there are a ton of different options available on the market. I'm sure a lot of them are great, and honestly I'm probably a little behind the times here as I'm still using a FlySky GT3B and Radiolink RC6GS as my primary transmitters. Both of these have been on the market for quite a number of years at this point, and there are much newer, shinier, higher tech options out there, but both of these have been working just fine and they do everything I need them to do, so I haven't really seen a need to upgrade. They're pretty basic, especially by today's standards, but for the majority of projects I do, I just need the steering and the throttle, and that's about it. But of course, not every transmitter is going to be compatible with every receiver, so that's something you'll need to keep in mind. If these are the transmitters I want to use with my smaller scale projects, I need to make sure that there are some good options available when it comes to compatible receivers. In the case of Radiolink, they have some smaller size RC car receivers, such as the R4 FGM. Not only is it small in size, but it also includes a built-in gyro, which can make driving easier by reducing oversteer. It accepts the standard 3-wire plugs for the servo and ESC, making this the better option for more of a plug-and-play type setup, with soldering not being required to connect these components to the receiver. An all-around really simple, really good setup, but for projects where I want the smallest size electronics possible, one product I really like is this DAS Micro 8-channel nano surface receiver. These are very small. In fact, they're intended for use in even smaller scale vehicles than the 1/24th and 1/25th scale models that I've installed them in. These receivers have been on the market for quite a number of years, so there may be some better options out there now, but I've had a lot of success with these. They're inexpensive, can be powered by up to around 9 volts, and offer up to 8 channels, which is really cool even though I've never had more than a steering servo and ESC connected, but that could definitely be helpful if you want more functions like additional servos being controllable. These might be available in different protocols for compatibility with different transmitters, but obviously I get the one that's compatible with my FlySky GT3B. To bind it to the transmitter, if I'm recalling correctly, you simply hold the bind button on the transmitter, then simply power on the receiver, holding the transmitter close to the receiver, and it should bind automatically within a few seconds. You'll see the red light stop flashing, though of course refer to the manufacturer's instructions when binding or setting up your receiver. It should be a simple and straightforward process. Now, while its smaller size makes it great for fitting into the model, the obvious potential downside is that this isn't exactly plug and play. To get it connected to your other components, you're going to need to do some careful soldering. There may be some other similar receiver options in a size similar to this that offers more of a plug-and-play type setup, but if you have a steady hand and good soldering equipment, get yourself some thin magnet wire like this, and make all of the connections as instructed by the manufacturer. For example here, the positive wire goes to the VCC, negative to the ground, and then channel 1 will get the signal wire from your servo, and channel 2 will get the signal wire from your ESC. But really, these have been sort of my go-to setups for these smaller scale models. The Radiolink RC6GS and R4FGM are a great combo. They're relatively compact, includes a nice built-in gyro, and it's more of a plug-and-play type experience. And then that FlySky GT3B, along with that DAS Micro 8-channel receiver, is for when I really want something as compact as possible that's going to be easier to hide away in the trunk or under the hood. Just gotta make sure I haven't had too many cups of coffee before getting this thing wired up. Perhaps not the latest and greatest in RC electronics here, but these components aren't very expensive, they're readily available, and have worked great for me, so for the time being I'm gonna stick with them, but again, like I said, there may be some better stuff out there. There really are a ton of different options when it comes to transmitters and receivers, so I'd definitely be curious to know what you guys like to use, but let's go ahead and move on to ESCs. Much like the radios, there are many different ESC options available on the market, but again, what we're generally most concerned with when it comes to highly detailed RC plastic models is their size. Some speed controllers are better than others, such as offering better low-end control, or in other words, operating much smoother at lower speeds. In addition to just the physical size, there are some other things you'll want to pay attention to. First, you want to make sure that the ESC has both a forward and reverse function. ESCs that don't offer this function are generally intended for aircraft. Some will also include a brake function. This means that when you're driving forward and move the throttle trigger to reverse, the car will stop. And then if you want to go in reverse, you can move the throttle trigger back to neutral and then to reverse once again. Some may operate like this right out of the box, while others may require programming. Another thing you're going to want to pay attention to is whether or not the ESC is designed for brushed or brushless motors. I tend to use brushed motors for most of these highly detailed smaller scale projects, so all the ESCs that I'll be showcasing today are designed for brushed motors. If you are looking to build more of a performance-oriented vehicle, brushless setups may be something to consider. And then finally, another thing we're going to want to pay attention to is how much voltage can the ESC handle. More voltage means more RPMs from the motor, resulting in a faster car, but generally ESCs capable of handling more power are larger in size. With this in mind, these have been some of my go-to ESCs. First off, when scale realism is a maximum priority and I want one that's going to take up the least amount of space, I really like using these DAS Micro 3A 1S LiPo compatible ESCs. These are tiny and very easy to hide just about anywhere in the vehicle, but again, this is not a plug-and-play option by any means, and it is only 1S LiPo compatible, so you're probably not going to be setting the pavement on fire with this one. Now let's say I want something with a little bit more pep, such as being 2S or 3S LiPo compatible. There do seem to be a number of ESC options available that are still pretty small in size, though can provide more power to the motor. This here that I'm showing on screen now is one that I've used previously for some projects, and even with its small size, it's still up to 3S LiPo compatible. Most of these smaller electronics I get off of AliExpress. Shipping times and occasionally the quality of some of these products can certainly vary, but it's not like these types of components are really something you're generally going to be able to find at your local hobby shop, so you kind of have to take what you can get. Also, there aren't many brand names when it comes to these ESCs, so it's kind of more about knowing what to search for rather than typing in a specific brand. Searching for something like Micro 2S LiPo Car ESC or something like that. And again, as you're looking through the results, keep in mind the stuff that I mentioned earlier. Make sure the dimensions are going to fit your car, handle the voltage that you want to run it on, make sure it's either for a brushed or brushless motor, and so on. But then if you're looking for something that's going to be a bit more of a plug-and-play type setup, an ESC like this one here that we sell on our site is a bit larger relative to some of these other ESCs, but you have the ability to simply plug everything in using these JST plugs. There are more options available when you're looking at ESCs that are more in this size range. It's a sacrifice of potentially being more difficult to hide in the vehicle, but with that sacrifice, you're getting something that's going to be way easier to hook up. I haven't used them as much, but there are some nice all-in-one receiver and ESC options available as well. Now is probably a good time to mention that if you're using a 2S or 3S LiPo battery to power the ESC and motor, but you don't want to send that much power to other components in your vehicle, I've used some of these tiny voltage step-downs before, and they can be a great option if you find yourself in that situation. This one here is fully adjustable. You just hook up the input on the one side, then use a small screwdriver and a voltmeter to adjust the output, and then you just install it somewhere in the vehicle. Sure, it's adding another component, but it is quite compact and not too difficult to hide. These are also super inexpensive to order. But I think that's about all I have to say as far as ESCs go. I'm still kind of experimenting and trying out different products myself, but when it comes to motors, I've definitely found a favorite. Now when it comes to motors, I really like these N20 and N30 size motor and gear reduction assemblies. I use these motors for just about everything, and you can get them in different RPMs and for different voltages. They're not the smallest option nor the fastest, but if you're just looking for something that's relatively small, has plenty of power, is very durable, and just works, it's just hard to go wrong with these motors from my experience. You can find these everywhere, and you can get them with a higher maximum RPM if you want the car to, well, not necessarily be fast, but certainly fast enough to have some fun racing around a track. And then on the flip side, if you want them to be smooth at slow speeds, you can choose a lower RPM version for something like an off-road 4x4. Now that said, there are a number of high-speed brushless options available on the market, as well as some really compact and super smooth options for microcrawlers such as the SCX24 and SCX30. I might try out some of these other options in the future, but I've really just stuck with these N20 motors and I've had a lot of success with them, and it's definitely my go-to for these types of projects. And then of course, to power everything, we need a battery. There's certainly no shortage of options when it comes to sizes and voltages. For my most detailed and lifelike projects, I'll generally choose to use a 1S LiPo battery, putting out a little under 4 volts. This is because they can be found in some very small sizes, such as the 70 mAh one that I got from Tiny Circuits. Now at 70 mAh, it's not going to provide a ton of runtime, but it will certainly be easy to hide in the vehicle. But when I'm willing to sacrifice a bit of room to have the car capable of traveling at higher speeds, I'll go ahead and use a 2S or even 3S LiPo, which can also be found in some pretty compact sizes, though generally will be larger than a 1S LiPo. These nanotech LiPos, for example, which you can get off of Hobby King, are a good option, and I would also suggest looking into smaller size LiPos available for vehicles like the Axial SCX30 and Low-C Micro B. Those seem to be pretty compact in size, and I've heard those can be a good option for these plastic model to RC conversions. Really, the most important thing to keep in mind is that your ESC and motor are able to handle the voltage that the battery will be providing. 1S LiPos will be around 4, 2S will be around 8, and 3S will be around 12. Again, be sure to reference the specs provided by the manufacturer before connecting anything together. For example, that tiny size Das Micro ESC that I showed earlier is only 1S LiPo compatible, So hooking it up to a higher voltage 2S or 3S is going to fry it, and once the smoke leaves, you can't put it back in. And then also, even though these batteries are quite small in size, it's still very important to keep LiPo battery safety in mind with regards to usage, storage, and charging. Proper usage and maintenance can also help greatly increase the lifespan of the battery. To steer the front wheels, we'll need a servo, and although you may think that the smaller the better, from my experience, that's true to a certain point. I tend to find some of these 2-gram and larger size servos are a good option, as going with some of these smaller options can sometimes not provide a sufficient amount of power. Even with some of these lightweight 1/24th and 1/25th scale models, it seems that the smallest size servos available on the market aren't always up to task and are prone to poor performance and premature failure. As an example, I've gotten a number of comments asking why I don't use these smaller linear servos for projects like this Chevelle. For reference, this is a 1.1 gram linear servo, which I think is about the smallest size of these that you can buy. While it is certainly smaller than the roughly 2 gram micro servo I have installed currently, it's not as though there's a huge difference in terms of the overall footprint and thickness of each at their thickest point. Smaller for sure, but not exactly a night and day improvement in terms of space required, though it may be easier to incorporate one over the other in certain situations. But then you have to think about the torque. For a long time, all of these micro servos and really anything remotely this size were specifically intended for lightweight micro aircraft. This has fortunately changed in more recent years as there's way more micro-size RC vehicles available on the market now, though when you tend to go this small, you still have to be careful with how much work you're requiring these servos to do. This 2-gram one that I have here is something that I think is sort of on the borderline of being acceptable, but you still sometimes have to be a bit careful not to overstress it. While I've never really had too many issues with these servos on 1/24 scale on-road vehicles, as you may recall when building and testing that 1980 Jeep J10, the off-road driving proved to be a little too much for these plastic-geared ones. Because of this, I stepped up to a more powerful all-metal gear micro servo with a similar footprint, which has proved to be a great option when a little more strength or turning speed is necessary without having to install a substantially larger size servo. Linear servos of this size are great for even smaller scale vehicles, such as ones more the size of a Hot Wheels car. However, once you start stepping up into the 1/24 scale range, you may start to have some issues with the amount of torque it's able to put out. But then also for this project in particular, I didn't want to use a linear servo as the rotation action of this servo here better matches how a steering gearbox would work on a real Chevelle. On the real cars, at least from the factory, they had a linkage steering setup with a gearbox, pitman arm, and drag link, which would be connected to the tie rods. The arm on the gearbox, which connects to the drag link, rotates. It doesn't move from one position to another in a linear fashion. I guess if you're trying to replicate something more like a rack and pinion steering system, a linear servo might make more sense for that. But being that I'm trying to replicate something as close as I can to the factory mechanics of a 69 Chevelle, obviously the rotation that this servo here allows for is more accurate to the steering linkage design that you'll see on the real thing. That's not to say a linear servo is necessarily a bad idea for projects like this by any means, but just something to keep in mind. This servo that I chose does come with some compromise, but I think the pros outweigh the cons in this particular instance. But of course, when you're building your own vehicle, I would encourage you to experiment and tinker with different designs and electronics and see what works best for you. We have some micro-sized servos available on our website, which is what I generally use, but like I said, if you need more power but don't want something substantially larger, this Surpass Hobby 2-gram all-metal gear servo is a great option. These are what I've used for my micro 4x4 projects where that bit of extra strength and durability is necessary for off-road driving. Certainly a bit more expensive, but if you want that extra power, you really can't go wrong. That's a product I would highly recommend for these types of projects. So there you go, there's a little overview of the electronics that I like to use for these plastic model to RC conversions. I certainly hope you found today's video helpful. Obviously, in this niche of the hobby, there is no one-size-fits-all solution, and again, I would really encourage you to test out some different things, experiment, and find out what works best for your particular build. I'm still tinkering and experimenting and trying out different things, so I definitely look forward to seeing what you all recommend below in the comments. When you're custom building things like this, stuff doesn't always go to plan. It's all just part of the process, and you just have to embrace the challenge and do the best you can. If you just want the experience of opening up a box and driving a vehicle right away with no issues, no tinkering, no challenge, again, there are a ton of products like that available on the market. But for those of us who don't just tolerate but actually enjoy the challenge, these types of projects are just so much fun. And I feel like I've been getting better and better with each one, at least I'd like to think so. Although some of these electronics can be a little tricky to work with, one silver lining is, at least by RC standards, all of these components are very inexpensive. So if you wreck one or burn something up, it's not quite as bad as when you're getting into the larger scale radio-controlled vehicles, where you can cook hundreds of dollars worth of components pretty easily if something goes wrong. If you have any questions, please feel free to leave them below in the comments. As always, a huge thanks to all of our channel members and Patreon supporters for helping to make these videos possible. If you're so inclined to hit that like button, it's greatly appreciated, and feel free to subscribe if you'd like to see some more videos like this one. More cool stuff on the way, but that's all I've got for today's video. Thank you all very much for watching, and I'll see you next time.